Hello, once again, a very good morning to you. We started with the combinatorics, which was divided into two parts, that is permutation and combination, and I gave you the formula. So let's try to recap a little what we have done earlier, okay? That is, as you know, that n factorial, which can also be written as factorial n, is a continuous multiplication of the natural number 1, 2, 3 up to n, right? So n is preceded by a number which is 1 less than n, like 3 is preceded by 2, which is 1 less than 3, right? So suppose you come across n factorial divided by n minus 1 factorial. What are you going to do? Because n factorial itself, it contains n minus 1 factorial, because from here to up to here, from here up to here is n minus 1 factorial. So this n factorial can be written as n minus 1 factorial multiplied to n, and down there in the denominator we have got n minus 1 factorial. Is that right? So we can cancel them away, and then we are left with n. So you got to get used to this sort of technique of cancelling the factorials, all right? Like for example, suppose I have got 10 factorial and divided by 6 factorial. Now we know that 1, 2, 3, 4 multiplied up to 6 gives us 6 factorial, which is very much present in 10 factorial. So 10 factorial could be split up as 6 factorial into 7 into 8 into 9 into 10, right? So 6 factorial remains there, so both can be cancelled, right? And you can write down the product of this one, 7 into 8 into 9 into 10, and write down the result, whatever comes there. Well, I forgot to remind you, I hope you all are with the pen and paper. That is a must for a mathematics class at least. You just can't do the things away with only listening, okay? We go to practice. And on the top of that, what did we learn? That is NPR or PNR was defined as what? It was defined as n factorial divided by n minus r factorial, where the value of r is always less than or equal to n. Fine? Right. So that is there. On the top of that, we have defined CNR also. What is CNR? Combination of n different objects taken r at a time, where the value of r is less than or equal to n. So that is defined as n factorial divided by r factorial and then n minus r factorial. So obviously when you look at these quantities, right, C and R is being divided by r factorial as well as n minus r factorial, whereas P and R is divided only by n minus r factorial. Obviously the value of P and R is greater than C and R. Fine? Okay. Well, apart from that, we have also noted that 0 factorial is defined as 1. Okay? Right. Well, regarding this factorial, we have done a sum last time. But now, let me recall an exercise that was set in one of your exams, that was show that. Okay, please take down. show that factorial twice n. What is factorial twice n? That is 1 into 2 into 3 into up to n, then n plus 1 multiplied with a greater quantity till it reaches twice n. So we can define this one as what? We have to show that this is equal to 2 to the power n, okay? Then n factorial, and within the curly bracket you have got 1 into 3 into 5 into 7 into, what will be the nth term? You all must have learned arithmetic progression, right? Arithmetic progression during your school days. So obviously the nth term is going to be twice n plus 1. Is that right? Check. How do you check it? Put n is equal to 0, then its value will be 1. Put n is equal to 1, 2 ones are 2 plus 1 is 3. Put n is equal to 2, 2 twos are 4 plus 1, 5. So this is the nth term, this is the first term, second term, third term, right? Okay. Well, you have to show that this twice n factorial is equal to that, and hence you have to show something else also. Hence, what is that? Prove that P twice n P twice n is equal to 2 to the power n, then 1, 3, 5, etc. going up to the last factor, that is twice n plus 1. Now you are allotted 5 marks for this. Okay, how are you going to attack the problem? That is the thing. Well, first of all, let us try to define what exactly is twice n factorial. Okay, we know that, right? We know what? Factorial twice n is defined as 1 into 2 into 3 into you go ahead till you reach n minus 1, then comes n, and n is followed by what? 2 is followed by 3, 1 is followed by 2, so n will be followed by 1 greater than this number, that is n plus 1, and then n plus 2, n plus 3, till you reach where? Till you reach twice n. So twice n will be the last factor, but before twice n, what are you going to have? You are going to have a number which is 1 less than twice n. That is what? Twice n minus 1. And as you can easily guess, twice n is an even number. Is that right? 2 multiplied to n may be anything, odd or even, but twice n always will be even, right? Okay, we have defined what is twice n all about. Now let's see what we have to get this, you see. Okay, let's try to separate out the even numbers first. What is that? 1, 2, 3 is followed by 4, 4 is followed by 5, 5 is followed by 6. So what are the even factors? Even factors will be 2 first, followed by 4, followed by 6, followed by 8, and your nth term will be what? Nth term will be twice n. So you bring the last even number, that nth even number here. Now this has been separated, so what you are left with? You are left with the odd factors. What are the odd factors? that is 1 into 3 into 5, because 2 has gone here, 4 has gone here, right? And followed by 7, in between the 6 has gone here, right? So till you reach where? Twice n minus 1. Easy? Okay. Now if you look at this, 2 into 4 into 8 into 6 into 8, you can write 2 into 1 as 2, and 4 can be written as 2 into 2, right? And then similarly 2 into 3, and then 2 into 4, right? Mind you, it is not 2.4 or something. We are multiplying 2 into 3, 2 into 4, until you reach 2 into n. And the rest is, of course, we'll just leave it like that. So separate it out, putting a curly bracket, 1, 3, 5, etc. till you reach twice n minus 1, right? Okay. So this part is already here. This is minus 1, sorry. It should be minus 1, not plus 1, okay? Yeah, because till we reach, yeah, that one. So twice n minus 1. So please, you rectify that one. Earlier I had written twice n plus 1, that was a slip. So please make it twice n minus 1. So we get twice n minus 1 followed by twice n. Okay. Now 2 is here, 2 is there, 2 is there, 2 is there, 2 is in the last nth term also. So how many 2's are there? Up to here there is 1, 2. This 2 and this 2 multiplied together gives you 2 square. Is it? 2 into 2 into 2. So 3 times if you multiply 2 together, it will give you 2 cube. So multiply this, it will give you 2 to the power 4. So this 2 also multiplied together, it will give you what? 2 to the power n. I hope I am clear to you. So 2 is being multiplied to itself n number of times. This is the nth term, so n number of times. So we will write twice n. Now these 2's have been taken care of. So what you are left with? You are left with 1, 2, 3, 4 up to n. So you are left with 1 into 2 into 3 into up to n. Fine? Okay. So far so good. Followed by 1, 3, 5, 7 till you reach twice n minus 1. Right? Okay. What is this in fact? This is just, what is that? N factorial. So we write twice n, 2 to the power n, then n factorial in place of this. And then the rest is what? 1, 3, 5, 7, okay? Till you reach twice n minus 1. Fine enough? Is it what you wanted to get? Yeah. You got to prove that factorial twice n is equal to 2 to the power n, n factorial followed by this. So that is what? Factorial twice n is equal to this. So you have shown it, right? Sure. Now the other part of the question, of course it carried 5 marks. Other part of the question is that hence prove that this is that. So what is this? Let's see. Now P twice n is defined as what? You know the definition of permutation. So it shall be what? Factorial twice n, right? I'm using this L sign for denoting factorial. And then down there it will be what? It will be twice n minus n. Is that right? When it was P n r, we have written n factorial over n minus r factorial. So when it is twice n, we will follow the same thing. Now what is the result? Result is, you know that twice n factorial we have already written like this, so you will have to take the trouble of writing that one. What is this? This is n 1, 3, 5 till it reaches twice n minus 1, okay, divided by what? Twice n minus n is n factorial, so n factorial. So these two n factorials are cancelling away, so you are left with what? 2 to the power n, then 1 into 3 into 5, right, till you reach twice n minus 1. Therefore, what have you done? P of twice n is equal to that. You are supposed to prove it, so you can write what? Proved. Okay, proved. Hope I'm clear to you, right? Okay, we'll go for the next exercise. Yeah, we are going to take another problem now that is also pertaining to permutation, all right? Permutation, and this particular question was set in the year 2015, right? 2015. And the question is like this. Question is, okay, let me write 15 in order to indicate that it was set in 2015. Find the value of n. Find the value of n. Hopefully you're writing, right? Find the value of n, then where is n? If permutation of n4 is 2, it is in the ratio form. Permutation of n minus 1 and 3 is equal to 9:1. And that carries 5 marks, right? So you got to be thorough with the definition of permutation. As you know that if it is P n r, you are going to write n factorial over n minus r factorial. So here there is 4 and there it is in place of n you've got n minus 1 and in place of r you've got 3. All right. So let's see the problem. Given, what is given? P n4 is 2. P n minus 1, 3 is equal to n 9:1. So this can be written as what? All of you have a very good idea about the ratio and proportion. If it is A is to B is equal to C is to D, we can write it in the fractional form. That is, A divided by B must be equal to C divided by D. And of course, the related things, you know that invertendo. In ratio and proportion, what is invertendo? If a relation is like this, you can write it as B by A upon D by C. That is, both of them are inverted. Okay. On the top of that, you have got something called componendo and dividendo also. What is componendo and dividendo? Componendo and dividendo is A is to B is equal to C is to D. Then componendo and dividendo gives you A plus B divided by A minus B will be equal to C plus D upon C minus D. So these are the things probably you must have learned in the school days. And you must have enjoyed it also. All right. Now, therefore, what does it indicate? P n r n4 divided by what? P n minus 1, 3 will be equal to 9 upon 1. 9 upon 1 is just. Now let's try to define what is P n 4 is all about. Alright, we got to write it properly. P n 4 will be what? N factorial. Let me use this symbol, right? Over n minus 4 factorial. Is that right? Okay. What about P n minus 1, 3? It will be n minus 1 factorial over n minus 1 subtract 3. N minus 1 minus 3 factorial. That is equal to 9. Right? Okay. That gives us what? Let me continue here. Okay. N factorial upon n minus 4 factorial. N factorial over n minus 4 factorial upon n minus 1 factorial, n minus 1 factorial over minus 1 minus 3. That gives you n minus 4 factorial, right, is equal to, let me write 9 only, right? Okay, here in the upper fraction you've got n minus 4 factorial in the denominator. In the lower fraction also you've got n minus 4 factorial in the denominator. So that can be cancelled away. I hope all of you know that. So ultimately what you are getting therefore n factorial divided by n minus 1 factorial is equal to 9. But you all know that n factorial contains n minus 1 factorial. So this will give you ultimately what? N minus 1 factorial multiplied to n. Is that right? N minus 1 factorial multiplied to n gives you n factorial. I split it up that one that way because of the fact that n minus 1 factorial was there waiting for you in the denominator. So this will cancel away. That is equal to 9, right? 9. Therefore, you got the value of n to be 9, right? Therefore, n will be equal to how much? 9. So that's it. Okay. I hope it is clear to all of you. So you can try it by yourself once again, right? So we'll go for another problem, right? I'll rub it up. Right. Okay. Now we'll take yet another problem, and then that is also pertaining to permutation. Okay, permutation, because as you know, so long as the digits are involved and alphabets are involved, then it becomes a problem of permutation, right? When the selection of engineers, the selection of doctors or advocates or headmasters or teachers or students are concerned, then of course it will be a matter of combination. That I have explained to you already. Hope you remember that. Now the next problem was set in 2017, not very long ago, 2017. See, the question says, how many words can be formed using the letters of the word I have written words because there are two words they have given. One is number 1 failure. Of course, you should be away from this. You should come to success. So, one is failure, and two, another one given to you was a daughter. D-A-U-G-H-T-E-R. Is that right? But there is a condition. If it is a straightaway question like this, then what will you do? You say that all the letters are different from one another. And here also there is no repetition. D-A-U-G-H-T-E-R. All are distinct alphabets. So, if the question is only like this, then your answer would be what? 1, 2, 3, 4, 5, 6, 7. It will be 7p7. And we have already, in our last class, we have seen that NPN or for that matter P and N is always equal to n factorial, right? N factorial. Because we have done this one as what? N factorial divided by n minus n factorial. That gives us simply n factorial divided by 0 factorial, but 0 factorial is 1, so the answer is n factorial, right? And if the question were straight away like that, then since there are how many? 4 plus 3, 7, it will, the first answer will be 7 factorial, number of words. It is not 7 words, it is 7 factorial words. That means 1 into 2 into 3 into up to 7. And here there are 8 letters. So 8 letters, your answer in 2 will be 8 factorial, right? But the question is not like that. Question is little more conditioner added. How many words can be formed using the letters of the word failure and daughter such that the vowels are not separated? That is the governing condition here. Vowels are not separated. All of you know what is vowels and consonants. In English literature, there are 5 vowels, A, E, I, O, U. So, is it present? Without a vowel, of course, there is no word. Or can you think of a word without vowel? Yeah? Is it a word without vowel? Okay. Forget about that. Here, where are the vowels? A, I, U, E. There are 4 vowels and rest 3, F, L, R are the consonants. Okay. Since the vowels are not to be separated, A, I, U, E, so we shall have to treat them as one letter. Okay. That is A, I, U, E. We will just try to think that this is just one alphabet. That is, wherever they appear, they will appear together. All right. So, including F, L, and R, it will make 4 alphabets. One alphabet is there, 2, 3, and 4. Right. So, the 4 alphabets will permute among themselves in how many ways? In 4p4 ways, that is 4 factorial way. But mind you, these vowels also will permute among themselves, right? That is A, I, U, E, they will interchange the place. In how many ways? There are 4 vowels, so they will interchange themselves in 4p4 ways, that is 4 factorial ways. So altogether the number of words that can be formed by using the letters of the word failure so that the vowels will never be separated will be 4 factorial into 4 factorial, right? So similar treatment you can give for the second one. Okay, let's try to write it down. Number 1, in the word we have to express a little so that your examiner will understand. In the word failure, F-A-I-L-U-R-E, the vowels are A-I-U-E, U and E, which can be treated, which are not to be separated, separated. So we treat A-I-U-E as one letter. And including the consonants. What are the consonants? F, L, and R. We have 4, because we are going to treat this one as one letter. So including F, L, and R, we have 4 letters which permute among themselves, right? Permute is a case of permutation. So permute among themselves. Permute among themselves. In how many ways? P, 4 ways. That is 4 factorial ways. But there is a big but. What is that? These vowels will also interchange. When they interchange, since there are 4 vowels, they will permute among themselves in the same way, 4 factorial ways. So since the 4 vowels will also permute among themselves, giving rise to more new words. And that will be B 4 factorial in numbers. So therefore altogether when they are not permuting among themselves, when the vowels are not permuting among themselves, you have 4 factorial. After that, when the vowels start permuting among themselves, you will get another 4 factorial ways. So altogether, the number of words, right? Number of words will be 4 factorial into 4 factorial. Yeah, number of words will be 4 factorial into 4 factorial. So that will be how much? You can just do it. What is that equal to? 1 into 2 into 3 into 4. So 1 can be set aside. 2 into 3 into 4 multiplied to 2 into 3 into 4. Right? 2 into 3 into 4. That gives you what? 24 into 24. Right? 2, 3 are 6, 4 are 24. 24 4s are, how much is that? Is it 96? Carry 9, 24, 2s are 48. 48 and 9 is 57. That is altogether, when the vowels are not separated, out of the word failure, you can make as many as 576 number of words. Right? Okay. I hope you'll be able to do this. So I'll leave it as an exercise for you to do it out. And in case you find it difficult, then you can certainly ask me, or through Sir Jeff also. You can go for some help there, right? Okay. All right. I think that is all for today, and we'll meet in the next class doing some more problem, okay? We are still with the combinatorics, so permutation and combination is also there waiting for us. We'll be doing a couple of sums from permutation once again, and then we'll go for combination, and then finally we'll go for binomial theorem, right? Okay. A long way to go, but we got to go faster, right? All the best to all of you. Have a nice day.